Hi Hires, so we are still looking at sustainability and interdependence and selecting and breeding in plant and animal breeding. So in particular we're looking at inbreeding and outbreeding. Okay, so these terms, you may have heard of inbreeding. I doubt you've heard of outbreeding as a thing. So what we normally have between animals and normal plant kind of production by cross-pollination. By cross-pollination we just mean between two different plants. They are what's called naturally outbreeding. And what we mean by outbreeding is that the parents are not closely related. So inbreeding, though, is what a lot of breeders are going to do, because what you're trying to do is to produce a true breeding pattern. So you're trying to get rid of your heterozygosity for a particular trait. Remember, that's what you're trying to do when you're breeding. So what you will do in plants is you will, it's kind of extreme inbreeding, you do self-pollination. So you take one plant and you take the pollen from that plant and use that pollen on the same plant. And that means that you're effectively just crossing it with its own genetic code. And in animals, you take closely related animals. And what you're trying to do there is fix a particular characteristic using the fact that they are showing those characteristics. What you're trying to do always is trying to make them homozygous for that particular gene. So for that gene, you only want one set of alleles that is always passed on and always gives the characteristic you want. Okay, there's a consequence of inbreeding over time, and one that, again, you may have heard the term inbreeding depression. Okay, so depression not as in sad, depression as in your gene pool has become lowered in terms of variation. Okay, so what we mean is that if you have a small gene pool that you're constantly pulling from, so by using inbreeding rather than outbreeding, then you get this build up. So you get a frequency of, and you need to use those terms, deleterious alleles. So deleterious as in bad. Okay, because if you are selecting from a small group of population, yes, you're selecting for one particular gene, the one you want, you're selecting for those alleles, but you're also pulling with it a kind of smaller and smaller other groups around the outside. So that is what we mean by inbreeding depression. Over time you can end up with other things that are causing problems. This is a example from history, the Habsburg lip, because what you had was some severe inbreeding in terms of the aristocracy at the time. So there are some dog breeds, in fact, just about every single purebred dog pretty much has a list of particular things that come with the fact that they have been selectively bred for a narrowed gene pool over time. Like your deafness in Dalmatians, 1/3 of purebred Dalmatian pups are bred deaf. And there are breeders who say that they should automatically be put down, so that they are not then increasing that in the population. So there are also, we would have to say, in each of these purebred ones, you have a higher risk of a whole pile of other common conditions that you would expect to see in any population with a lower genetic diversity. So this is a little bit extra, but it was in the original hire, and I still think it's worth you kind of seeing it. So there are some ways that you can avoid inbreeding depression, and some plants have been doing it for years, and like thousands. So there are plants that naturally self-pollinate. So a lot of our crop plants are actually naturally self-pollinating, that have naturally self-pollinated for hundreds of generations. So what's actually happened is that they've gone through inbreeding depression, the deleterious alleles have built up, but any plant that was ending up with those means that they have a selective disadvantage, so they're not then passing on to the next generation. So what you're actually doing is you've kind of edited out these alleles, but that's a pretty drastic way to do it. Still in the extras, but the ideas are nice to kind of think through. Okay, so if you have a group that you're now starting to worry about the potential for inbreeding depression, then you may be able to take parents that are homozygous for the thing you were looking for originally, but have good heterozygosity in everything else. So basically you're avoiding inbreeding depression by literally stopping inbreeding, taking an organism which is from a distant relationship to the one that you're looking at, bringing it in. Okay, if you don't have the option of kind of changing what's there, you can still pick and choose which individuals you are having in the breeding setup. So if you think about zoos, captive breeding, especially captive breeding and release programs, you will choose exactly which breeding partners you have, trying to maximise the outbreeding you have. And then the other option is to crossbreed. So that means to take two closely related breeds and use them together. But I'll talk a little bit more on that when that's still in the course content. And here we go with crossbreeding. So crossbreeding means that you take two purebred strains and you cross them, and then because you've crossed them, the idea is that you'll get the best of both, but also what this will do is hopefully help inbreeding depression, because as you've crossed them, you've got increased heterozygosity. And once you've got that crossbreed, you've got two options. You can either back cross to take a particular trait that you've now got with the crossbreed, or what you can do is you can keep two purebred lines and then you just keep breeding them to just give you the desired crossbreed. So you have like the Labradoodle or similar ones. Okay.